Hello students, today's discussion is about simple harmonic motion. Actually, simple harmonic motion, the chapter name is what? Waves and oscillations. Waves and oscillations. So carefully, this is what very important. Waves from it's linked with the second year part and oscillations is from first year. So from the simple harmonic motion, the basic definition, first it starts from what? What is motion of the particle? What is motion? Okay. So first one is about what is motion. Motion position means there are three types we can classify them. There are three types we can classify. First one is about translatory motion. Translatory motion. Next one is here oscillatory motion. It's a oscillatory motion. Next one is rotatory motion. It's a rotatory motion. So from the translatory motion, if you see about this translatory motion, okay, oscillatory, next one rotatory motion. Now first from the translatory motion, transfer of force from one body to another body. During this year, when body is placed on a horizontal surface, so this is the ground, okay, body of mass m, if I apply a force on this, okay, it can be translating along with in the direction of applied force. In the direction of applied force. So body moves in direction of applied force. Okay, and that also we can say it's a straight line path. This is straight line path. This is about translatory motion. So next one, oscillatory motion. For oscillatory motion is what? To and fro. To and fro. Towards. This is what? Towards. Fro means what? It's a backwards. Is the backwards. Rotatory motion towards and backwards. So this is translatory. What is this? Oscillatory motion. Okay. So next one is about vibratory motion. Also we can say. We can also say vibratory motion. Vibratory motion. Rotatory motion is when particle moves along with curved path. During this curved path, when the particle is moving along with the curved path, during this condition, translatory motion is converting into the rotatory motion. Means a special case of rotatory motion. Rotatory motion is what? Special case of rotatory motion is circular motion. Circular motion. So what is the special case of this? Special case, I said you that it's a special case of rotatory motion is what? Circular motion. What is the special case? The special case is radius vector remains constant. radius vector remains constant. Radius remains constant. Radius remains constant. So this is about rotatory motion. So our concept is to discussion is about which one? Oscillatory motion. Oscillatory motion, that's what? Vibratory motion. So in oscillatory and vibratory motion, for the first condition is about what is periodic motion. What is periodic motion? Periodic motion means what? If any particle is moving along with the same path in equal intervals of time. So here I can say that periodic motion is what? Particle repeats. So same path. It repeats along with the same path and in equal intervals of time. Equal intervals of time. The time interval is what? Same. It repeats along with the same path in equal intervals of time. So what do you say example for this? The example is motion of planets. Motion of planets around the sun. Motion of planets around the sun, okay, is what? Periodic motion. Motion of the planets around the sun. So this is the sun, okay. Here planets are revolving around the sun. So in equal intervals of time, path is same path. Same path means what? Repeated path. Okay, it's a repeated path. And time interval is same. That's what? Time interval is same. Is the same time interval. Okay, so you can choose about this is the motion of this any planets around this, like in equal intervals of time. This is called what? Periodic motion. So in the periodic motion here, so periodic motion, particle has to be moved along with the same path in equal intervals of time. Oscillatory motion is the motion of the particle. Motion of particle. So motion of particle, that should be towards and backwards. From mean position. Mean position means it's a fixed position. So this I can take about mean position means a fixed position. So this is towards and backwards. Towards means you can say to and fro motion. So this is called oscillatory motion. In oscillatory motion, so many examples we can write for this. First one is about simple pendulum. It's a simple pendulum. Okay, so you know simple pendulum is one of the examples of here angular oscillations. Oscillations are two types, just we discuss. So angular oscillation, linear oscillations. Linear oscillations means oscillations along with the same straight line path. Okay, so simple pendulum, just what? Simple pendulum. The pendulum is, this is the fixed position. Here is a position. This is what just I'm taking as a fixed position. I have taken this from here to here. It moves towards, okay, again comes back, okay, it's what? Backwards, towards, next one, backwards, okay, towards and backwards. So the to and fro motion, so this which makes an angle theta with the vertical, okay, this is called about simple pendulum. So later we discuss about the complete discussion about simple pendulum. So this is the fixed position, I can say. It's a fixed position. This fixed position is called mean position. This last position from the mean is called what? Extreme position. It's a extreme position. So this one also extreme position, right? So extreme position on either sides of mean position are there, okay. So this is simple pendulum. And one more example we can say spring mass system. Spring mass system, okay. Spring mass system is just have taken a fixed position. From this spring is taken, it's what? Mass m, spring's constant is k. When you pull down to this position, okay, will come to the, so like oscillates from this mean position. This is called mean position. These two positions, this is called displacement. It's x is the displacement. These are called, what you say? Extreme position. Extreme position, okay. So here also same, it's a extreme position. So this is what spring mass system is an example for what? Oscillatory motion. So vibration of a string in sitar, vibration of a string in sitar, vibration of a string or vibration of a wire in guitar, okay. So like all these are examples for what? It's a oscillatory motion. So next one, after this oscillatory motion, what is harmonic? Harmonic motion, okay, harmonic motion. So don't get confusion about periodic, it moves along with the same path in equal intervals of time, okay. So oscillatory, it moves to and fro from a fixed point. This is a fixed point, means what? Towards and backwards will be taking like. So harmonic motion is what? So the motion of the particle means what? Here, if the motion of particle, okay. So as a trigonometric function, okay, as a trigonometric functions, okay, trigonometric function. So, and one thing I said from this, first one is about trigonometric function we discussed. This is what? Trigonometric function, okay. And in the trigonometric function, first thing you should know about, should has, it is in the function that is what? Sin theta or cos theta, sine function, cosine function like, and should has this fixed, okay, fixed amplitude, fixed amplitude. The amplitude is what? A, which is maximum displacement from the mean position. So that is what? It's a it should be the fixed one. So this can be expressed as what? Harmonic function, okay. It's a harmonic motion, okay. So in harmonic motion, finally we came to the conclusion y is equals to a sin theta, or y is equals to a cos theta. A stands for what? Amplitude. Okay, it's a amplitude. So same in both the cases. So y is equals to a sin theta, y is equals to a cos theta. I can also write a sin omega t. So this is what? A cos omega t. Omega is what? Angular velocity. Okay, it's what? Angular velocity. So these are called what? It's a harmonic functions. Okay, so this is what? Harmonic functions or harmonic motion. The particle executing what? Harmonic motion. And one thing, so this is what harmonic means. What we said about, it's a trigonometric function. Okay, trigonometric one. It should be expressed in what? Sin theta and cos theta. So its amplitude is fixed. Amplitude is fixed. A is what? Fixed. Its displacement can be expressed as y is equals to a sin theta and y is equals to a cos theta. Okay. So just I'm talking about for the next one is about here. If we say, just you put it as a note. Okay. The note is what? Sir, you are saying about this harmonic function. Okay, harmonic function is okay. That's what harmonic motion. What do you mean by non-harmonic motion? Non-harmonic motion, which we said the amplitude, no, this is not constant. Okay, so put it as a note for non-harmonic motion. Non-harmonic motion. Non-harmonic motion. Now for non-harmonic motion, amplitude is varying. Okay, it's what? Varying. Varying, it means what? It's a not constant. This is not constant. Okay, so what trigonometric functions can be expressed? If I say sec theta, okay, cosec theta, okay, cot theta, okay, other than this. So like we can express. So these are what? Basically formed by, it's a sec theta, cosec theta, cot theta. Next one is what? Tan theta. Like this is for non-harmonic motion. In the non-harmonic motion, amplitude does not remain constant. Okay, so it's what? Varying. It's a not constant is the condition for this. What the basic meaning of oscillatory means what? Oscillation and vibration. So what is the basic meaning of oscillation and vibration? So before knowing this one, I should know about what is restoring force. Restoring force is, it's a, if I am saying this, is the restoring force, the force which brings back a body or the particle to its initial position. Okay, so which brings back means what? Force which so brings the particle, okay, to its initial position, or original position. So I can say this is what? F is proportional to minus x. It means the force, restoring force is so opposite direction to its displacement. F is equals to minus k into x is the restoring force. So what's the meaning of this minus? Minus is what? Restoring force. So it's what? Restoring force acts opposite direction to displacement. Restoring force acts opposite direction to displacement of particle. It's a displacement of particle. So this is about restoring force. Okay. So after this, from the restoring force, now I want to talk about this. What do you mean by this term exactly? How can you represent oscillation and vibration? For the oscillation and vibratory motion, okay, so I'm choosing about like this is what is a reference point, means origin in the coordinate system. It's a time, okay. This is what it's a position of the particle, okay. So it started, for example, this one wave, another, okay. So like I has taken this. Now we can observe this here, same amplitude. Both of these, what it's in a same amplitude. So this one also will be what with the same amplitude. Either sides. This is what mean position. It's a the line this express about this mean position. So this is what A. It's a minus A. A never be negative, but minus A indicates other side of this oscillation. So this is from year to year. This I can say as, okay. So from this point, year to year is what? Time period. Time period is okay. It's a time period. Next one, from here to this one also. This is what one wave. So here to here also, it's a time period is what? T. Okay. Yes. So the time period means what? This is from here to here is completing one wave. From this is the mean position. From this position, particle is moving up and down, means what? To and fro motion. This is called maximum displacement from the mean position, which is known as amplitude. Okay, it's a amplitude. So this one also same as amplitude in opposite direction. So this is another wave. Okay, it's what? Another wave. Yes. So what is the total? The time period of this one is what? To completion of one wave is what? It's a T. Okay. And next one, this is what? Again, one more wave is formed. So number of waves produced per 1 second is what? It's a frequency. Okay. Frequency. So the frequency is what? Total 2. Okay. Time period is what? It's a T. For complete up to here, frequency is what? 2. And next one, this is what? One oscillation. Yes, it's a one oscillation. So this is another oscillation. From here to here is what? One other oscillation. Like we can say here oscillation. Yes. So this is here I'm trying to say from just oscillation and vibration means what? From the mean position, the maximum displacement from the mean position gives what? Amplitude, and it has completed one oscillation. Okay. Next one, another oscillation. The time taken to complete one oscillation is called what? Time period. So this is also another time period. Okay. So how many waves we have? There are the 2 waves are formed. Its frequency is what? 2. Okay. So next one, how do you define the time period? The time taken to complete one oscillation. Particle to be started from the mean means what? From any position if we take, and should complete one oscillation. That is what? Like started from here to this one. So one oscillation, the time taken is what? Time period. It's a concept of types of oscillation, types of simple harmonic motion. So earlier we discussed it about, so simple harmonic motion. One is about, okay, so linear oscillation, linear simple harmonic motion, angular simple harmonic motion. This is what? Linear SHM. Linear SHM. Next one is about second, angular SHM. It's a angular SHM, simple harmonic motion. Okay. So for the linear SHM, if we choose about is a straight line path on this one. So a spring is attached to here. Yes, like this. A block is placed here. Its mass is M. Yes, this is the mean position from here. Okay. So it may displacing from here to here when I apply the force, and so like we can take the displacement is what, it's a x. This one is also what you say, it's a x. So okay, so it's what, it's the same particle of mass M. This is called linear oscillation, linear simple harmonic motion. The SHM along with same straight line path. Okay, same straight line path. So same straight line path. Yes, the parameters are different that we discuss. And next one about angular oscillation, angular simple harmonic motion, like this we can say. So here is the simple pendulum which makes an angle theta. Okay, so it moves to and fro. Okay, so towards and backward direction. This is called what, angular SHM. This position, so these are the positions, like it's a mean position. This is what, extreme position. So either sides it's a extreme positions, like. So this is about angular SHM. So angular SHM, right? So for the angular SHM, what things to be remember? For the first one is about very first case I am talking on this. For the angular SHM, it should be, okay, it should be, so the particle which is moving along with the same path. Okay, so then what I am talking about angular SHM, it should be means what, the particle should be. So okay, it should be oscillatory. It should be oscillatory. Oscillatory means what, to and fro from a fixed position, and it should be the periodic motion. Okay. Second one, acceleration. What is that acceleration? Acceleration means magnitude of acceleration. Magnitude of acceleration is directly proportional to displacement. Okay, magnitude of acceleration is directly proportional to displacement. Okay, so next one, for the third condition, restoring force F must be is equals to what, minus kx. Okay, F must be is equals to minus kx. Here one point we can add this, acceleration of the particle executing SHM always directed towards to mean position. Okay, acceleration directed towards mean position of the particle, mean position of this SHM system. Okay, so this is what angular oscillation. Mass, position of center of mass, position of center of mass, position of center of mass. So these are the methods for problem solving. Carefully you can observe this. Position of center of mass. So position of center of mass is, first if we say the displacement of particle in SHM. Displacement of particle in SHM. Simple harmonic motion. So displacement of particle in SHM, you can continue writing this. Okay. Displacement of particle in SHM. For example, if we choose for the first example one I am taking as, this is simple pendulum. Okay, is the best example for simple harmonic motion. It's making oscillations. It's what, towards and backwards, like this we can say. Okay, it makes an angle theta either sides from the vertical. You know, this is what mean position. This is what extreme position. It's a extreme position. So this one also extreme position. It's a extreme position. So this is, it is an example for which makes an angle theta in simple harmonic motion, which makes an angle theta. Theta means what? This we can say as angular oscillations. Angular oscillations. It is an example for angular oscillations. Okay. In angular oscillations, so this is mean position means what? We need to treat it as x is equals to what? 0. Particle starts from mean. So it's what? X is equals to 0. The maximum displacement from here is called what? It's a amplitude. Maximum displacement from the mean position is called what? You say it's an amplitude. Okay. This displacement, I said you what? What is the displacement? Displacement is what? The displacement of the particle. Displacement of the particle from here to here. For example, just to see, if it has started from this position, which position? Started from extreme position. It moved from here to, again came to the same point. Okay, this is called one oscillation. It's A, this is O. Okay, next one is, if you say this is what? B. If it is started moving from A to O and B, again came back, so this is called one oscillation. Okay, so if particle okay completes, moves, okay, particle moves from which point? From A to O to B, A to O to B, again from B to O to A and reverse. Okay, came to the same point. So that is called what you say? One oscillation is called one oscillation. Okay, this is what? Oscillation. It's a oscillation. Yes. So for the oscillation means what? Started from A to O, again B to O, again O to A is called one oscillation. The time taken for complete one oscillation, is called time period. Okay, it's a time period. So time period is denoted by capital letter T. Time taken is denoted by small letter t. Okay, time taken is denoted by small letter t. So started from where? For example, here. It's where? From this position, which is the position from here. It moved from which point? Extreme point. Okay, from extreme to what distance it moved? From extreme to what distance? Means what? This is the distance traveled. The distance traveled may be from A to O, or A to half of that, or 1/4 of this, or anything like. So this we can say what? Displacement of the particle from, so position, that position can be, for example, if it come to this position, this is called what? It's a position. Okay, so position means what is the distance of the particle from the mean? That is called what you say? It explains about position. Okay, from the mean position. So you may ask us, sir, position can be measured from mean or measured from extreme. Anyone, your wish. Okay, you can measure from the extreme. If you measure from the extreme, so cos function, and if you measure from the mean, it should be what? Sine function. Okay, that I will show it. Okay, now very careful on this. Just linear oscillation. So from the linear oscillations, if you observe from this, Okay, linear means what? It should be straight line path. This is the straight line. Same as usual, what we said the positions, it's what? X is equals to 0. Okay, so this is what? X is equals to A, and it's what you say? X is equals to minus A. Amplitude never be negative, but negative means what? It indicates what? Left side from the mean position. Okay, so this, you know, it's what you say? It's a mean position. Okay, this is called mean position, same as usual. So what we completed, that's what? It's a extreme position, same as you say. It's what? Extreme position. This is extreme position. Okay, now come to the point. X is equals to 0, X is equals to A, X is equals to minus A. So my question is about here, first one, this explains about, so from the linear oscillations also. Okay, so I can write it as displacement of particle, otherwise position of particle. Position of particle. So position of particle, let it be, it's what? X. Why it should be X? It is along with X axis. If it is along with X axis, position of particle, what do you say? It's a X. Now here we can say this is X is equals to A sine omega t. X is equals to A sine omega t. Okay, so X equal to A sine omega t means what? Particle starts from where? Mean position. It starts from, particle starts from, okay, starts from where? Mean position. It starts from mean position, then we need to use this formula. When we use X is equals to A sine omega t sine function, so particle starts from where? It's a mean position. If it is here, X is equals to A cos omega t. So when do you say X is equals to A cos omega t? So whenever particle, okay, this is what? Particle starts from where? So it's what? Starts from extreme position. Okay, so this is what? Extreme position. Particle starts from the extreme position. That's it. So what is the displacement, or what is the position of the particle in SHM? Position of the particle in SHM is given as, what is the formula? X is equals to A sine omega t, X is equals to A cos omega t. Now the question may be raising on this one. So before this, I want to draw the graph on this. Okay, the graph is what? Graph, it's a, so graphical representation. So graphical representation. So graphical representation is what? Here position is taken along with the y-axis. Okay, this is what? Time. It's a t. Yes. So for all the cases, this is what? It's a position. It's a time taken. Now, which is the equation? Particle is starting from the mean position. Just to imagine that particle is started from mean position. So which formula we have to use? Particle started from mean position. X is equals to A sine omega t. Okay, so just you write here, what is this? X is equals to A sine omega t. Now we check it as, first of all, this is the one position. First one is one position. Okay, so let it be, this is what? Time period. Up to here the wave has completed. Okay, it's what? Already we said that sine and cos functions, if you are using, this is called what? Harmonic motion. Harmonic motion means what? So the SHM which can be expressed, the motion of the particle which can be expressed. So sine and cos functions means, what do you say this one? It's a harmonic motion. If it is harmonic motion means, you can say this A is constant, amplitude is constant. Okay, non-harmonic motion, if he is asking for example, amplitude is not constant. So amplitude, fixed amplitude. For example, here to here what? How much it is moved? The same. For example, 5 centimeter. Next side also 5 centimeter. Here 5 centimeter, here 6 centimeter. It's not like. This is called not harmonic motion. Okay. So first one, it's what you say. This is what t. Right. Okay. Perfectly. Time period. Okay, so it's what? T by 2, half of the time period. Next one is what? Again half, T by 4. Next one is what? 3T by 4. It's a 3T by 4. Okay, so in this equation, if I substitute as in place of T 0, where is the in place of T 0? Here. If I substitute in place of T 0, where you get the position? T equal to 0. So omega into 0. Sin 0. Sin 0 value? 0. 0 into something? 0. X is equals to what? 0. X is equals to 0. So okay, X is equals to 0 means this point only. This is my, so this is the point. Next one. So you choose it as X is equals to A. Next one, X is equals to minus A. Okay, X is equals to plus A, X is equals to minus A. Okay, so like I'm choosing as this is, okay, so the positions I want to represent like. Next one, here this is, okay, a T by 4, and next one it's a T by 2, it's a 3T by 4, and next one it's a T. Yes, so next one, just let me check it about this. First one, X equal to A sin omega T means like this we written. X is equal to, in place of T, if I substitute as, in place of T, if I substitute, so that's what, here at this position, for example, T by 4. If I want to use T by 4, substitute now in place of T by 4. What do you get on this one? In X is equal to A sin omega T. So this is what just I'm writing as X is equals to A sin omega T. In place of T, you substitute T by 4. Omega means what? 2 pi by T. Okay, omega. So X is equals to A sin omega means what? 2 pi by T into what? T by 4. T and T cancel. 2 ones, 2 twos. Pi by 2. Pi by 2 is 90. Sin 90 value 1. 1 into A. So then what you got? X is equals to what? A only. X is equals to A. A means what? T by 4, what will be this? This is A. Like the wave is what? It's a sinusoidal. It's a sinusoidal wave. Okay. So this is what? From here to here is called one oscillation. Is called one oscillation. X is equals to A sin omega T. So it means what? It means what? Particle is started from this. Okay. So from this you can say particle is started. Okay. Particle is started from mean position. From mean position. Okay. No issue on this. From the mean position. A particle is started from mean position means what? Just I'm using, this is what? Here X is equals to 0. And next one is what? X is equals to A, which is amplitude. Here next side is what? X is equals to minus A. First question from this. The question is from here. Sir, what is the time taken by the particle to move from X is equals to 0 to X is equals to A? Time taken by the particle to move from X is equals to 0 to X is equals to what? It's A. Then how should I write this one? X is equals to A sin omega T. Why you are writing about this X equal to A sin omega T? Particle is started from mean. Mean means what? Sine function. Mean means what? It's a sine function. So X is equals to A sin omega T. My here up to where? From here to here, what is the displacement? A. So that's what? X is equals to A. In place of X, you need to substitute as A. A is equals to A sin omega T. It's this cancel. 1 is equals to sin omega T. In sine table, where you get 1? For 90 degrees. 90 degrees means what it say? Pi by 2 is equals to, what do you write? Omega T. Pi by 2 is equals to, omega means what? 2 pi by T. Okay. So then T is equals to, what is the condition? It's a T by 4. Yes, t is equals to, from x is equals to, we can say as x is equals to a sine omega t. X is equals to a sine omega t. Then t is equals to, what do you write? It's a t by 4. X is equals to, for example, if I ask the question here. Yes, what is the displacement from here? X is equals to a by 2. X is equals to a by 2. Just let me check on this one. In place of x, what should I write? A by 2. A by 2 is equals to a sine omega t. A cancel. 1 by 2 is equals to sine omega t. In sine table, where is 1 by 2? 30 degrees. 30 degrees means what? Pi by 6. So what do you say? It's a pi by 6. Pi by 6 is equals to omega t. Pi by 6 is equals to, omega means what? 2 pi by t into what? T. Pi and pi cancel. So then small t is equals to what? T is equals to, t is equals to t by 12 is the relation. The time taken from here to here is what? T by 12. Next I'm doing about this. For the third one, just I'm doing cross check. Cross check is what? Sir, here to here is what? T is equals to what you got? T by 4. But this one T is equals to what? T by 12. From where? From here to here. Correct? Sir, can you say, so what is the time taken? So from here, this to this. What is the time taken? Time taken total is what here? T1. This is what it say? T2. T1 minus T2. Isn't it? Total time taken is what from here to here? It's a T by 4. This one is what? T by 12. So then, for example, if I say this is T1, T2, can I take it as T3? Yes. So T2 plus T3, T2 plus T3 is equals to what? T1. Okay. So T2, it's a T by 12. T3, don't know. Then T1, T by 4. T3 is equals to, T3 is equals to T by 4 minus T by 12. I want to get it as 12 as a denominator. It's what? 3 by 3. 3t minus t? 2t. 2t by 12. 2t by 12 means what? T by 6. This is what? T3. Time taken from x equal to 0 to x is equals to a by 2. X equal to 0 to x is equals to a. So x equal to a by 2 to x equal to a. Sir, particle started from mean. Which formula we have to use? Sine function. Particle started from extreme position. Which formula we have to use? Cos function. Let me check on this one. Sir, particle is started from this. Okay. So particle is started from here to here. Let it be. I want to check on this. What is the time taken to move from here to here? T by 6. Moving from extreme to means what? So next one is, this is third. As a fourth one I am writing is, so from x is equals to a to x is equals to what? What is this from here to here? No, this is a. This become as what? A by 2, na? A by 2. So it's what? A by 2 you can try. So from where to where? Here to here. Which formula I have to use? Sine or cos? Cos. Then what? X is equals to. X is equals to. Okay. So it's what? A cos omega t. Just I am doing this. X means what? A by 2. A cos omega t. A and A cancel. 1 by 2. Okay. So this is 1 by 2 is equals to cos omega t. In cos table, where is 1 by 2? 60. 60 means pi by 3. Isn't it? It's a pi by 3. This is pi by 3 is equals to omega t. Omega is what? 2 pi by t into what? T. This cancel. Okay. So then this is small t is equals to what you write? T by 6. Are these two equal? Yes or no? So if you use from the mean to extreme, T by 6. Okay, so that's what from year to year I have chosen from this. Next one is from year to year I have chosen. Next one is for the cross checking from year to year I am using this one. This is the position of the particle. So it may be from sine function or cos function. If you use a sine function, particle started from mean. Okay, cos function, particle started from extreme position. Okay, so let us take a question on this. One question. So the question is what? Roughly you can copy. An object performs SHM of amplitude 5 centimeter, of amplitude 5 centimeter and amplitude 5 centimeter and time period 4 seconds. Time period 4 seconds. Time period 4 seconds. If started from an object from center, if object is started from x is equals to 0. X equal to 0 means what? Mean position. Okay. Started from x is equals to 0. Okay. Then calculate question number 1. First one. Frequency of oscillation. Frequency of oscillation. Second, the displacement at t is equals to 0.5 seconds. Please try. Check again this type of question as a dependent of time function. This, so an object performs SHM. This is given as what? Amplitude. Amplitude is what? A. Its time period is given 4 seconds. An object started from x is equals to 0. X equal to 0 means it's a mean position. Okay. So mean position means he's asking about what? What is the frequency of oscillation and what is the displacement? Frequency. So frequency is what? Reciprocal of time period. Then frequency f is equals to 1 by t. 1 by t means what? 1 by 4. It's a 0.25. Here, second, the displacement at t is equals to 0.5 seconds. 0.5 seconds means the displacement as a function of time. Here time taken. Okay. So this is what? Time taken. So x is equals to 5 sine omega means what? 2 pi by t into t. So then 2 pi by t means what? It's a 4 and small t is 0.5. So you got it as, after the substitution, x is equals to what is this? 5 sine pi by 4. Sine pi by 4 means what? 45 degrees. 45 degrees value is 5 by root 2. Okay. So is the answer according to given options? We can give it as like it's a 5 by root 2. Otherwise multiply and divide with root 2. So 5 root 2 by 2. 2.5 root 2, like we can write it. It's in a centimeter. Okay. So next one. One more question I'm giving as this. So displacement of a particle. Next one. the displacement of a particle, displacement of a particle executing SHM, displacement of a particle executing SHM. So y is equals to 0.08 sine, y is equals to 0.08 sine 3 pi t plus pi by 4 meter. This is x. So means y is given along with the y axis. Some equation is given. Okay. So you first of all, let me complete the question. This, and he is asking about first one, find time period, second frequency, third amplitude, fourth, okay, initial phase. Next, fifth one, initial displacement. Okay, like this. And some time will be given. Same earlier we did not, t value what, 0.5. At t equal to 0.5, what will be its displacement? Anything like. So these are the questions from this. First one, very first condition about this one. This is in the form of y is equals to a sine omega t plus phi. A sine omega t plus phi. So a is what? Amplitude. So what is the amplitude? 0.08. Okay. For the first one, so this is what, here you can write 0.08. If it is mentioned in the meters, we need to write in the meters. Next one, it's omega. What is the omega? Omega is what is it? This is multiple of t. So then what? Omega is equals to, we can write for what? Omega is equals to 3 pi. Omega means what? 2 pi by t is equals to what? 3 pi. Okay, 2 pi f also we can write, but I want to know about this t. Yes, so this pi cancels. Then t is equals to what happens, ma? So t 2 by 3 is equals to t, correct na? Then t is equals to what do you write? 2 by 3 seconds. What is the time taken? T means what? So this will be cross multiplied. Next one about, if he is talking about the frequency f is equals to 1 by t. 1 by t means what? 1 by 2 by 3. 3 by 2 second inverse. 1 by second. Okay. So time period we have, what is this? 2 by 3 seconds. And the frequency we have 3 by 2 second inverse. What is initial phase? What is initial phase? For the fourth question I am trying this one. This total is what? It's a phase. This total is called what is it? It's a phase. Yes, so is the phase. Ma, initial phase, phi initial means t is equals to 0. At t is equals to 0. So what is the phi initial? This is equals to, what is condition? Omega t plus phi. T equal to 0 means this total term is 0, right? 0 into something is 0. So what is the answer now? Phi. So what is the phi is given here? What is the answer? Pi by 4 radian. Okay. Initial displacement. Okay. Initial displacement is what? Directly I am writing this 0.08 sine, what do you say? It's a, this part is 0, right? Correct, no? What is there? Pi by 4. Initial, when he is saying, that is what, t is equals to 0. What do you write? 0.08 into 1 by root 2 is the condition. Yes. So like this type of question, some equation will be given. Okay, so from the equation he would ask us some selective points from this according to the given options. So next one, concept of velocity. Concept of velocity of particle. Velocity of particle in SHM. Velocity of particle in SHM. Concept of velocity of particle in SHM. So second model, so concept you are doing this one, velocity of a particle in SHM. So velocity of a particle in SHM, this is SHM. If you say SHO, SHO stands for simple harmonic oscillator. Simple harmonic oscillator. Simple harmonic oscillator. Okay, is the concept from this. So first one, what is the velocity of SHM? Velocity of SHM. Yes, first let me know on this. What is the displacement given? Position. Position is what? X is equals to A sine omega t. If I want to know velocity, how should I get this one? V is equals to dx by dt. D by dt times of x means what? A sine omega t. Differentiate. Differentiation of sine theta, cos theta. Differentiation of cos theta, minus sine theta. Okay. So d by dt of sine, it's what? A. D by dt of sine omega t, cos omega t. Again omega t differentiation is what? Into omega. D by dt of omega t is what? Omega. So this is d by dt of omega t will be what? It's omega into dt by dt. What is the answer? Omega. Yes. So this is equals to, we can say, A omega cos omega t is the velocity of particle in SHO. Sir, cos function there, no. Particle started from mean position, no. From where you got this? This is your condition. It is from where? Sine. Sine means particle started from mean. So this is also from mean only. Okay. So I'm doing all the cases in with the mean position only. So V is equals to, what is the condition? A omega cos omega t. Okay. First one, velocity V is equals to A omega cos omega t. Yes. This is time dependent function. So two cases we are going to discuss. Earlier also we said for the displacement, position dependent, at x is equals to a by 2, what is the time taken? X equal to a by 2. At t equal to 0.5, where is the position? Yes or no? Position dependent, time dependent. Two types of questions we will be asking. So V is equals to A omega cos omega t is called what? Time dependent. Time dependent form of velocity. For the position dependent, if I want to discuss about the position dependent, then what do you say? It's a sine square theta plus cos square theta is equals to 1. Cos square theta is equals to what? 1 minus sine square theta. Cos theta is equals to what? Under root of 1 minus sine square theta. Okay. So here V, I am writing this V is equals to A omega. Cos omega t means what? Under root of 1 minus cos omega t. What is the cos omega t here? 1 minus sine square omega t. Sine square omega t. Okay. So here we can say Sir, what is this sin omega t? X is equals to what is the condition? A sin omega t. X is equals to A sin omega t. Then sin omega t is equals to what? Sin omega t is equals to x by A. So we can write V is equals to A omega under root of 1 minus sin omega t, sin square omega t, x square by what? A square. Sir, I want to write along with y axis y square by A square. No issue on this one. So this is what V is equals to A omega times. So this will be what? A square minus x square by what? A square. One A cancel na? This comes out of the root, correct? So what will be your final answer? The final answer is what? V is equals to omega under root of A square minus x square is position dependent form of velocity. Okay, so this is what you say, it's a position dependent. Position dependent. Yes, so first one I got it as time dependent. Next one is what? Position dependent. Okay, so let me know, so where the velocity is maximum and where the velocity is minimum. Velocity is maximum for the case 1. For first one I am talking on this case 1. So at mean position means what? Particle started from mean position means what is x now? X is equals to 0. In place of x equal to 0, if you substitute, what is this? V is equals to. In place of x, here is 0. What is the condition? Omega under root of A square. Square root cancel. What is the answer? V is equals to A omega. This is what? Maximum velocity. So where velocity is maximum? Where velocity is maximum? At a mean position. Okay. So velocity is maximum at the mean position. Right. Next one for the case 2, if you see this. Case 2. Yes, from the case 2. Case 2 means what? At extreme. At extreme. X is equals to what? A. V is equals to what? Omega under root of A square minus x square. A square only. V is equals to what? 0. Omega into 0. Something into 0 is what? 0. So this is what? Minimum. Okay? Minimum. So from this what you got it, understand? Sir, this is what? X is equals to. So from here if you see this, it's what? X is equals to 0. X is equals to what? A. X is equals to what? A. What is the velocity here? V is equals to A omega. Sometimes he won't say maximum velocity, minimum velocity. He will say velocity at mean. Velocity at mean means what? Maximum velocity. So here velocity at extreme 0. Here 0 means here also 0 only now. Okay. So this is the thing to remember. So where it is here the particle at the mean position and extreme position, the velocity components. And velocity time dependent function V equal to A omega cos omega t, and position dependent is what? V is equals to omega under root of A square minus x square. Okay. So now I want to represent a graphical presentation on this. Graphical presentation is this is given set t. Okay. So same as this is what? Velocity. Okay, velocity. So same the situation earlier what we completed. Okay, so here first I am taking as this is the maximum part of velocity. Okay, here other side of this, and next one at t equal to t by 4, at t equal to t by 2. Okay, 3t by 4. Next one t, one wave. Okay, so first one here we can say as this. V is equals to what is the condition? What is the velocity? Velocity is what? V is equals to A omega cos omega t. At t is equals to 0. V is equals to what? A omega cos 0. Is 0 only, na? 0 into something 0, right? Then cos 0, correct? Cos 0 value what? 1. So what is the answer? A omega. It's a omega. A omega means what? A t is equals to 0. This is a omega. This is what? Minus a omega. Particle started from where? This. Now here. Next, let me check on this. Another one. But t is equals to, what is the second one is? T by 4. This is what? T by 2. This is what? 3t by 4. This is what? It's a t. One wave. One sinusoidal wave. So here for the sine function, what we started? From here, correct? Yes or no? For cos function is what? T is equals to, so V is equals to A omega. Here it is at this position. And next one at T is equals to T by 4. I am doing this. V is equals to A omega cos omega times of, what is the T? T by 4. Correct? Cos omega T. So then V is equals to A omega cos, omega means what? 2 pi by T into what? T by 4. Then T cancel. 2 ones to 2's. Pi by 2. 90. Cos 90. 0. So 0 into something? 0. What is the velocity here? 0. So at T equal to this one, where is the position? This. Right? So same like if you go on this, then T is equals to 0, T is equals to T by 2, T is equals to T by 4, T equal to 3T by 4, T equal to T. Okay, if you substitute, so the wave is what? Like this. This is one wave. So this is what? One oscillation from this up to here. T equal to T now. It's what? One oscillation. Yes. So what is the time period here? Time period is what you say? It's a T. T is the time period. This is the, so just a graphical presentation of this velocity versus time. Velocity versus time means what? Like this we can write it as. And next one here, just I want to do this one. So velocity versus time. Velocity versus position. Okay. A graph is what? Velocity versus position graph. Velocity versus position. First you take about what is the velocity position relation. V is equals to what? Omega under root of a square minus x square. Carefully, important. Squaring on both sides. V square is equals to omega square times of a square minus x square. V square by omega square is equals to a square minus x square. Okay. So which is there? Velocity versus position means what? Velocity is taken along with y-axis. Position is taken along with the x-axis. Okay. So first, just I am dividing with this one all the cases. So V square by a square means what? Omega square a square plus x square by a square is equals to a square by a square. Do you agree with this? Careful. First, dividing all the cases by a square. Correct. X square by a square. Bring here. Got it. So what is the condition? V square by omega square a square plus x square by a square is equals to what? 1. This is general equation for what? Ellipse. Okay. It's what? Ellipse. So this is what? Ellipse. How this ellipse is formed? Now, so what do you say from here? First condition, what is there? V square by omega square a square plus x square by what? a square is equals to what? 1. This is position, velocity. Velocity versus position. Okay. So, now I taken as a graph. Is a case. Yes, ma. This is velocity, right? It's a position. The graph is what? It should be like this. Yes. So this is a maximum value. Okay. It's what? It's a maximum value. Maximum value is what? A omega. The length from A to here is what you say? A omega. This length is what? X. X means what you say? It's a only, na? So in along with x-axis, what distance is there here? A. Yes. What is there along with y-axis? V. V. Correct? V square by. So A omega whole square plus along with x-axis. So it's what? X square by A square is equals to what? 1. Okay. So it means what? X square by A square plus Y square by B square is equals to what? 1. Is the general equation for ellipse. He will give this values, some particular values would be mentioned here. He would ask us, so what is the omega or what is the A like? Is it okay? Yes. So for example, I am taking as this is an example I am taking as this. From this is the graph. Okay. It's what like. Okay. So this is what? It's a 20 meter per second. This is velocity versus it's a position. So this is what, for example, it's a 5 meter. Isn't it? So do you have any like individually omega and A? No. So which graph is this? Velocity versus position. So velocity versus position means what? You should know this value is what? A omega. A omega is equals to what? 20 meter per second. 20 meter per second. So along with x-axis, what is this A? A is equals to what? 5 meter. You would ask us time period, frequency, omega, anyone. So this is what? First one. Amma, A omega by A is equals to, what is the A omega? 20. A is what? 5. What is the answer? 4. A cancel. Correct. Omega is equals to 4 second inverse for angular frequency. Radian per second if you mention. What is this? Angular velocity. Okay. So it is mentioned second inverse. What do you say this one? Angular. Yes. Angular frequency. This is mentioned in what? Second inverse. Is okay. So this is the relation about what? It's a velocity. Velocity as a function of position, as a function of time. Yes. So let us go for few questions based on this. For the first question linked with this one. So the question number 1. Do it as roughly. Amplitude of harmonic oscillator. Amplitude of harmonic oscillator. Amplitude of harmonic oscillator is A. Is A. Next. When velocity of the particle is half of maximum velocity, when velocity of particle is half of maximum velocity. Half of maximum velocity. Determine position of particle. Position of particle is the question. Check the question is now. Amplitude of harmonic oscillator. Amplitude as given. Amplitude is what it say? Let it be A. Harmonic oscillator is, this is what? Write A. It's A. When velocity of the particle is half of maximum velocity. Velocity is equal to, what is the maximum velocity? A omega by 2. A omega by 2. Determine the position of particle. So what we know this is, velocity v is equal to omega under root of a square minus x square. What is v? A omega by 2. Yes, mentioned. This is what? V is equal to a omega by 2. It's a omega by 2 is equal to omega under root of a square minus x square. Omega, omega cancel. This will become as what? A by 2. A by 2 is equal to under root of a square minus x square. So squaring on both sides, a square by 4 is equal to a square minus x square. Then x square is equal to, bring. Then what happens? A square minus a square by 4. X square is equal to 4a square minus a square, 3a square by 4. Then x is equal to under root of 3a square by 4. It means what? X is equal to root 3a by 2. Is the case? This is the x. At what position? Velocity is half of maximum velocity as given. Like we can write it as. So this is one model of question. And next one, the next model of question, the displacement of particle in a SHM is given by this. Y is equal to 3 sine of 100 t plus pi by 6. Okay. Meter. Calculate. Just I am asking V max. It's a very simple relation. V max means what? What is the condition V max? A omega. So you can write this. This is what? What is here? Say omega. Correct. What is this? It's a. So V max is equal to A omega. A is 3, omega is 100. What is the answer? 300 meter per second.